homework that I anticipate was a little bit tricky, and then we'll talk about what your practice is today. So on the homework, there was a question where it said, find the absolute extrema of g of x equals sine of x plus pi over 4 on the interval 0 through 7 pi over 4. It's okay to just write pi as pi. So remember, the candidates test requires 3 steps. Find the endpoints, find the critical points, find the candidates test. So we know the endpoints are x equals 0 and x equals 7 pi over 4. That comes from the interval. To identify the critical points of f of x, sorry, in this case I should have said g of x, we would have to set the derivative of g of x equal to 0. But first we need to look at g of x and see, well, what type of rule, derivative rule, do we need to apply to find the derivative? In this case, there's a function within a function, so I'm going to need the chain rule. Okay, so go ahead and do the chain rule right now. I'm going to pause the video to have that written out. Okay, so the chain rule, find the inside function, rewrite the outside function, make sure the very last step is to sub back in that inside function, that u function, into the derivative of the outside function. So we get g prime of x equals cosine of x plus pi over 4, quantity times 1. Times 1, meaning you don't even have to write that, right? So if you looked at this and you're like, oh, chain rule, you can even do the chain rule in your head and realize that the derivative of g of x here is cosine of x plus pi over 4, since the derivative of the inside function is 1. Okay, so now that we have that, you're going to go to your graphing calculator, and let's go ahead and find the critical points by finding the x-intercepts of this derivative function. Let's go do that now. Desmos.com/calculator. And we're going to type in that derivative function, cosine of x plus, and to write pi, you're going to write pi divided by 4, and it automatically translates it. Close that parentheses. Double check that you're always in radian mode by clicking this gear button over here. We're in radians, great. And the interval that we're looking at, I like just bracketing that out here. We're looking from x equals 0, x equals 7 pi over 4. That helps me realize what part of the graph I'm focusing on. I'm going to drag this over. You see our blue line, our green line. Let's zoom in a little bit. Okay, so here we have it. And what we need to do now is we're going to find where are the critical points by finding the zeros of this graph. So it looks like one of the zeros is right here at pi over 4. And another 0 is at 5 pi over 4. So we're going to go ahead and write that as our critical points. And you can just write pi as pi. There we go, we have our critical points. Now we're going to take our critical points and endpoints, which are both our candidates that we're testing, and put this into our table to check out which one gets our absolute max and which one gets our absolute min. Now remember that when we're doing the candidates test, we look at the original function. That's where we're plugging in these candidates to see in the original function which one has the absolute max and absolute min. So I'm going to go back to my Desmos calculator. I'm going to clear out these functions because this was for the derivative function. I'm going to type in my original function. It was sine of x plus pi over 4. And then we're going to click our gear button, click the table. You can clear that stuff out and just write in those candidates that we just found. So 0 and 7 pi over 4 are our endpoints, and then our critical points were pi over 4 and 5 pi over 4. And this is beautifully set up here. So we get 0.707, 1, -1, and 0. Let's type that in. I'm actually going to just take a screenshot, but you can type it in here. And what I can do is just paste it into my slide. This is where the whole unit circle thing is going to be relevant. If you notice, if we plug in 0 into the sine function, sine of 0 plus pi over 4 is sine of pi over 4. Sine of pi over 4 is square root of 2 over 2 when we did that friendly angle chart. So to be even more precise, we could say square root of 2 over 2 over here. Okay, so which one is our absolute max? Which one's our absolute min? Yes, so our absolute max is going to be at pi over 4, and our absolute min is going to be at 7 pi over 4. Oh, wait, nope, just kidding. Just kidding. Our absolute min is going to be at 5 pi over 4, since negative 1 is smaller than 0. Okay, so go ahead and write that in here. G of x has an absolute max at x equals pi over 4, and an absolute min at x equals 5 pi over 4. And if we asked about value, you would tell us the y value, and you can always add that to your sentence. So that